Hey guys, we want to look at how we can compare numbers and fractions. And I do not mean that you are comparing both together. I mean how you can compare numbers separately and then how you can compare fractions separately. By the way, this is Fun Maths with Excel, and thank you so much for following this video. If you have not subscribed to this channel, please do so now. Thank you so much. Now, to compare numbers or fractions, we are simply trying to state if the numbers or fractions are equal. All right, we're trying to state if they are equal or if one is greater than the other. That is, one is less than or is greater than the other. So we are just trying to understand what is really happening between either of numbers or fractions. Okay, and so we have the symbols we use in comparing numbers. And so let's go into it. We have this symbol for comparing numbers. This symbol means less than. Okay, and you could just take your arms up and put it in that, bring it towards your chest. Take your arms up, bring it towards your chest as if you want to elbow. You'll be able to have that shape. It means less than. And if you have your left hand right to the screen, and that is less than, your right hand is greater than. So the symbol for greater than is this, greater than. All right, and then of course we already know this is equal to. Okay, so we have other symbols, but that's really for inequalities. We have the equal to, greater than or equal to sign, but we are not going into that. I just want to show you. Look at this. Okay, so we have this symbol. Okay, this is a less than or equal to sign. Okay, and this is a greater than or equal to sign, and then we have not equal to. Okay, these are mostly used in inequalities, but that's not what we are doing today. And so our concentration for this class would be to talk about this, okay, using this signs. And so we are going to be starting. We have been able to cover the equal to sign in some videos in the past, so please just look at that. That is especially balanced equations. Okay, and when you have an equal to sign separating two operations or three operations, it simply is trying to tell you that what is on the left hand side is equal to what is on your right hand side, whether it's an algebraic equation or not. Okay, it's just telling you that what is on the left hand side is equal to what is on the right hand side. Okay, and so let's take examples to see how this can be done. We go back to our drawing still. So look at this example 1. If you have the number 2, okay, and 3, in size is 2 smaller or bigger or larger than 3? Is it? Of course, that's no. And so since it is not, we are going to say 2 is less than. Okay, that's the symbol for less than. 2 is less than 3. Okay, and so if we have something like 8 and we have a bracket asking us to compare these numbers, obviously these are equal to. So 8 is equal to 8. Okay, so if we have something like, say, the same 8 and we are being asked to compare these numbers. Okay, and so we know that 8 is greater than 3. All right, so this is how we compare numbers. It's as simple as that. But when we start going into operations, okay, operations that are a little bit complex, then we begin to see which to do. But let's say, for example, we have 3 times 2 plus 1, and we're asked to compare. Okay, we're asked to compare this. Okay, and 3 plus 6 divided by 2. Okay, of course you know that we are going to be using BODMAS to solve this question. So here the left hand side, and this other is the right hand side. So let's solve the left hand side, which is this. 3 times 2 is 6, plus 1 is equals to 7. Let's solve this other one. 3 plus 6 is 9. Okay. Divide by 2. Oh, remember we are using our BODMAS to do this. So this would be 6 divided by 2, and that's 3. That's 3. So that 3 plus 3, that would be 6. Now we have 7 on the left hand side, and we have 6 on the right hand side. We can clearly see now in this question that 7 is bigger, so therefore we say 7 is greater than 6. Okay, and so this is how we compare numbers. We can have even algebraic equations. We can compare numbers in algebraic equations. That is equations where we have unknown variables. Okay, but let's see another simple question as this. Say we have open bracket 3 square plus square root of 25 plus 6 on our left hand side, and we have square root of 16 square times 2 on our right hand side. Okay, and so if we have something like this, obviously we are going to be solving them one after the other. So in this case, 3 raised to the power of 2 would be 9, plus square root of 25 is 5. Okay, and this would be, okay, plus 6. So 9 plus 5 is 14, plus 6 is 20. Okay, so we have that. Let's see what we will have in the left hand side or the right hand side. In the right hand side, we have the square root of 16 is 4, raised to the power of 2 is 16 also. Alternatively, this can cancel this and cancel this, so that you have 16 just in the bracket, and times 2, this is going to be equals to 32. All right, so if we look at this, what we now have is 20 and 32. So let's do that. 20 and 32. So if we have 20 and we are asked to compare with 32. We can clearly see that 20 is less than. So it's less than 32. We'll just do this. Okay, this simply means less than 32. Okay, the bracket there is just showing the square there. It's just telling us there's an empty something there. Okay, so this is how we compare numbers. But it begins to change when we now start to compare fractions. Okay, and it's very easy. It's very easy. When we compare fractions, we are simply trying to find out which is greater and or if they are equal. And this is important because sometimes we cannot tell. Say for example you have this fraction 1/2, okay, and 3/6. Okay, you cannot tell which of these fraction is smaller or bigger. And so by looking at it, one will assume that this is bigger than this, but that's not the case. Okay, and so to be able to find out, we need to bring this to their smallest fraction. That is, we can simplify. The 1/2 there has been simplified to its least fraction. But these 3/6 can be further simplified. And 3 into here is 1, 3 into here is 2. And so that means we have 1/2. You can now see that these fractions are equal. And since they are equal, we call them equivalent fractions. Fractions that are equal as these are called equivalent fractions. Okay? They are called equivalent fractions. Now, we can have also other kinds of fractions. When we have fractions that have the same denominator, like this, say 1/4 and 3/4. In this case, the denominators are the same. Alright, the denominators are the same. And so we can simply look at what we have at the numerator at the top. We can look at what we have at the top, okay, to compare. And when we look at the top here, we can clearly see that 1 is less than 3. And so in this case, we say that 1/4 is less than 3/4 as a fraction. All right. So this is how we solve. This is how we solve questions that have the same denominators. But we have questions that do not have the same denominators. And in cases like that, we are going to employ two methods. One method is cross multiplication, and then another method is to convert the fraction to decimals. Okay, so let's look at how we can compare 2/5 and 3/4. You can see that the denominator here and this one here are different. They are different, and so we can use any of these methods. Either we are cross multiplying, which is cross multiplication method, or we can use the conversion of the fractions to decimal method. Okay, so let's look at how we can use either of the method. The first one, in this case, when we have something like this, we can cross multiply. We can cross multiply. And so when we cross multiply this, 4 times 2, we are going to have 8. and that will be 8 over 5. And when we have 5 times 3, we are going to have 15, and that will be 15 over 4. Now we can see that 8 is smaller than 15, and since that is what we are having here, we can simply say 8 over 5 is smaller, okay, or is less than 15 over 4. It also means that the original question will also be this way, okay. Okay, so this is what it means. All right, we can have the other method. Let's see how we can use the other method to solve something unique. Okay, and so let's say we have this same question and we want to convert each of this. So we are going to first of all remember it's 2 over 5 and 3 over 4. Okay, 3 over 4. So here we are going to change it to decimal, and that's to divide. That's to divide. So we have 2 here, and then we have 5 here. 5 into 2 cannot go, and so we can say 0 and have a point here. And since we have a point here, we can have a point here. It also means we can have 0 here. All right. 5 into this, 20 now. You look at this 2.0 as 20, and so that will be 4. Okay. And 5 times 4, that will be 20. And when we subtract this, this will be 0. Please, if you're having difficulty understanding division, look up our videos, the video we've done on division, and that should be able to guide you. We've done simple division and long divisions, even decimals and all of that. Please look at them and it will help you. And so, but for these also, we can have 3 and 4. Likewise, it cannot go into that. So we have this, and we can have this 0. 4 into 30 will give us 7 times, and this will give us 28. When we subtract, we will have 2. Okay, and it means we can have another 0 here, which we can bring down. And 4 into 20 is 5. And so 4 times 5 is 20. We can subtract this and have 0. So all of this means that this equation here, all right, is 0.4. This is 0.75. 0.75. Okay, we can clearly see here also that 0.4 is less than 0.75, and so we can just use our less than. This is how we can convert, either using the multiplication method or using the conversion of the decimal method. So let me know if you have questions in your comment section, anything you do not understand, and something you need clarification on. Please, if you haven't subscribed to this channel, please do so. It helps to keep the algorithm going. Thank you so much for following this video. Bye for now.